We are extremely privileged to invite Professor John McNeill to join us at Global Asia, Conversation with the Scholars at Duke University. I am Yuan Chen, Environmental Humanities Fellow of the Global Asia Initiative and the Franklin Humanities Institute. Professor McNeill is the Distinguished University Professor of History at Georgetown University. He's a member of the American Academy of Arts and Sciences and also a member of the Academia Europe. Professor McNeill's groundbreaking work, Something New Under the Sun, An Environmental History of the 20th-Century World, received the World History Association's Book Prize and was named to the Times of London's 2008 list of the 10 best science books ever written. Published in 2010, his book, Mosquito Empire, Ecology and War in the Greater Caribbean, 1620 to 1914, won the American Historical Association's Beveridge Prize and a Prose Award for Best Book on European and World History. His other books include The Atlantic Empires of France and Spain, The Mountains of the Mediterranean World, An Environmental History, The Great Acceleration, An Environmental History of the Anthropocene since 1945, and most recently, The Webs of Humankind, A World History. Professor McNeill served as the president of the American Society for Environmental History from 2011 to 2013, and the president of the American Historical Association from 2019 to 2020. Thank you. So, Professor McNeill, your new world history book, The Web of Humankind, it is a fascinating account of global history through the lens of connections and communications. Please let me first tell you what Professor Duara just wrote to me last night about your book. And he wrote, I am just amazed by the incredible breadth and the depth of his knowledge that he has organized in such a clear narrative form. His idea of intensifying and pulsating webs of connectivity from prehistoric times is the best approach to global history, and he does it more successfully than any I have seen. That is his comment, and I cannot agree more with him. I wonder if you can first introduce to the audience, especially those who have not yet read your book, what new sources have you utilized in writing The Web of Humankind? And how did you identify the underlying connections and maybe undercurrents when you gather and synthesize historical sources from different cultures and different regions in this global web?
Okay, Yuan, thanks very much for engaging me this way in this interview, and thanks to Prosenjit for his over-the-top generosity in his assessment of that book. So, with respect to new sources, and that is evidence from the science that's increasingly called paleogenomics, and some new evidence from new technologies of archaeology. Paleogenomics refers to the study of the past through the study of genomes. That can be genomes of living creatures, whether human or non-human, but it can also include fossil genetic evidence, often called ancient DNA. And geneticists are doing fantastic work in this general arena now. And I tried to incorporate some of that, particularly in the early chapters where textual evidence is either non-existent or slender.
Thank you for the introduction. As an Asianist, I cannot help but be attracted to the cover image you have chosen for this volume. This is created by the second to last emperor of the Northern Song dynasty, which you mentioned in your book, Emperor Huizong. It is actually an imitation of an 8th century painting of a Tang dynasty artist Zhang Xuan. It shows
court ladies preparing newly woven silk. As you have mentioned in your book, this painting of silk weaving shows the intended work for Chinese women at the time, but it also is a very vivid illustration of the keyword web. I think that's why it's chosen as the cover image. Since this is the Global Asia initiative at Duke, I wonder if you can specifically talk about the place and the role of Asia in the forming, in the maturing, and the weaving of the global web.
First, let me say, Yuan, you know more about that cover image than I do, and your analysis of it is deeper than mine. Now, the role of East Asia in all this. So the way I see it, human communities have always been linked in some vague and tenuous ways, but in certain parts of the world, those linkages over time grew more robust, stronger, tighter, and formed what I call a web, at first a local web. And East Asia was one of the first places that this happened, the first in what is now North China. But East Asia is one of the earliest webs, as I see it, and gradually becomes one of the largest, a slow process over many centuries, and not one that is without its ebbs and flows. Even though the general historical direction is towards larger and tighter webs, and at various times and places, webs can unravel for perhaps centuries. East Asia, as I say, is one of the places where this process gets started early and a tight interactive web develops, partly because of favorable situations for transport of mass bulk goods, a lot of navigable rivers. That was developed and exploited by various societies with canal building to make the most of riverine transport. And that helps to make the East Asian web more robust and resistant to unraveling than that in some other parts of the world. The East Asian web gradually links up to other webs. It has powerful connections to the Indian Ocean world in the first millennium and the second millennium as well. In the Mongol centuries, its connections to Western Eurasia magnify. And then in the 15th century, due to maritime connections, some of which were initiated by the Ming, some of which were initiated by Iberians, the East Asian web is gradually combined with other webs to form a truly global web in the 15th and 16th century for the first time. And from that point forward, my book abandons the vocabulary of East Asian web, or for that matter, any other regional web, and speaks only of a global web.
Thank you, John. I wonder if we can move on to talk about your work in progress, if you don't mind, the ecological process of the Industrial Revolution that you're currently working on. The Industrial Revolution has already been intensively studied in the past, but you are casting a new light on the Industrial Revolution by looking at the ingredients. I'm borrowing your word. I wonder if you mind introducing what kinds of ingredients of Industrial Revolution have you chosen for your study, and why these ingredients? And also, how can these ingredients tell us something new and revealing that earlier studies of the Industrial Revolution have missed?
What I hope to do in this book is present the 19th century Industrial Revolution as a global process from the beginning, on the grounds that various minerals, fibers, lubricants, and other ingredients of industrialization came from the four corners of the earth. In the initial stages of the Industrial Revolution, they were transported in ever-growing quantities to the lands of industrialization, Britain, parts of the European continent, parts of Eastern North America. But it is the production of these mineral ores, fibers, lubricants, and the ecological ramifications of producing them in ever greater quantities that I'm most interested in. So that's all background. The ingredients that I expect to focus on with respect to mineral ores will be copper, lead, and tin. With respect to fibers, it's likely to be cotton, silk, and wool. With respect to lubricants, palm oil, which we know is a food additive, but before it had its career as a food additive, it was a machine lubricant, and sperm whale, which was famous as an illuminant, but also was very valuable as a machine lubricant. And I expect to include a couple of other things, a dye stuff that comes from the heartwood of a tree native to South America, gutta percha from Southeast Asia, which was used as insulation for undersea telegraph cables. I'm particularly interested in items that came more or less directly from the natural world and were essential to some aspect of industrialization, and aside from cotton, whose stories are not all that familiar. But I want to bring all these together, put them side by side, so to speak, and argue for a vision of the Industrial Revolution that puts at its center what I'm calling ecological teleconnections, the long distance linkages between zones where lead was mined or gutta percha was collected and the factories and mills of industrial landscapes. And I'm really, really interested in the knock-on ecological effects of producing so much gutta percha, so much sperm whale, so much bison leather or elephant ivory.
Is there any evidence of the long-term ecological consequences of the teleconnections you have just mentioned?
Yes, to take some obvious examples, the tremendous effort to secure elephant ivory for industrial production of things such as piano keys and billiard balls in the 19th century probably reduced East African elephant populations by 50 to 70%. And elephants serve as environmental regulators. They are a keystone species. Through their routine behavior, they have a powerful effect on the balance between grassland and forest land. And if you take most of the elephants out of the East African landscape, forest advances at the expense of grassland. And with more forest, there's more habitat for tsetse fly, the vector for sleeping sickness, and a livestock disease often called nagana. They're both manifestations of trypanosomiasis. So the disease landscape of East Africa was altered in part because of the elephant hunt. And that remains in effect, so to speak. The elephant populations have never recovered. In fact, they have dwindled further, especially in the last 60 years or so. And there are other examples of durable environmental changes that resulted from the quest for these ingredients of industrialization. In fact, in just about every case, I think I can claim that the effects linger into the 20th and 21st century.
I think this is very illuminating now that you're writing in the Industrial Revolution this way. So now we are able to understand it by the way you have just described, to understand it not as an English process, but a global process. And it's not just an Industrial Revolution powered by the coal in England, but also powered by everything from the four corners of the world, as you have just described. I look forward to your new book.
And it has an East Asian component in the following sense. I envision a final chapter that addresses the general theme in the context of the modern and ongoing industrialization of East and Southeast Asia and the ecological teleconnections that link, for example, Chinese industrialization with Australian coal or African copper.
Mhm. That actually had some big ramification last year when China stopped to import the coal from Australia. And that arguably led to the electricity crisis at the end of last year. Some very interesting teleconnections, as you have described.
All the teleconnections, while I'm describing them mainly in ecological terms, they all have social and political manifestations as well. And I do expect to write a little bit about them, but my main focus will be on the environmental and ecological aspects of this story.
That's wonderful. I look forward to the new book. I now want to move on to the big topic of the Anthropocene, or maybe a little bit of cliche topic of the Anthropocene, but I think it's important. For example, your book, Something New Under the Sun, was published before Paul Cruzen first coined the word, or maybe more precisely, recuperated the word Anthropocene in 2002. But I have this impression, and please correct me if I'm wrong. My impression is you have already written this entire book about Anthropocene, although the word did not really appear in the book. And then you have become one of the most active and prolific scholars of the Anthropocene. You co-authored, for example, with Paul Cruzen on how humans are overcoming the great forces of nature. And this book of yours, The Great Acceleration, is entirely dedicated to Anthropocene since 1945. Not to mention that you are also a member of the Anthropocene Working Group, which has been actively working on formalizing the identification of Anthropocene as a geological phase. I have many questions that I want to ask you about Anthropocene. I wonder, can you start by telling us about your collaboration with Paul Cruzen? And what is your view on the different theories or different schemes about the origin of the Anthropocene? I know you have your own view, as you already provided the date of Anthropocene Ground Zero in the title of your book here. But I wonder if you can comment on the merits and maybe deficiencies of different periodizations when different scholars try to pin down the start of Anthropocene to the invention of agriculture, to industrial revolution, to capitalism, or to the nuclear test, as you yourself have proposed.
Okay, Matt, a lot of questions there, Yuan. So first, as to my collaborations with the late Paul Crutzen, who died just a few months ago, we did co-author 2 articles in, I believe, 2007 and 2011. And one of the things I learned from that experience is that when you co-author a paper with a Nobel Prize winner, you don't necessarily get the last word. And that's reflected particularly in the first of those articles, the 2007 piece, because that one more or less accepts Crutzen's chronology of the Anthropocene, emphasizing onset of the Industrial Revolution. And I had already come to the opinion, which is reflected in Something New Under the Sun, the 20th century, and especially the second half of the 20th century, was something new. I did not conceive of it in Earth history terms. And so it never occurred to me to give it a name such as Anthropocene. I understood it as something new in environmental history terms, not in Earth history terms, not in the history of the planet, not stretching back 4 billion years. But my point here is that by that time, I already thought the second half of the 20th century is when things really change fundamentally. And that the Industrial Revolution was a precursor to that, important, essential, but only modest in its environmental impacts in many parts of the world. Although I'm exploring this more carefully now in the book project that we just talked about. As for the various proposed birthdays for the Anthropocene, I am among those who think that the second half of the 20th century is the best choice. I say that mainly because of all the variables that are reflected nicely in a series of graphs put together by the International Geosphere Biosphere Project, in which there are lots of curves of things from 1750 onward, and they almost all slope upward sharply around 1950. These are things like global water use, energy use, population, both things that are driving forces behind global environmental change and also manifestations or indicators of global environmental change. And there's just so many of them that show this approximate same trajectory, emphasizing the middle of the 20th century as a point of inflection on the curve. I'm also influenced by working together with geologists, especially stratigraphers. That's the subset of geologists who worry about the strata in the Earth's surface and subsurface within the Anthropocene Working Group. And for them, any new interval of geological time has to be synchronous. So it can't start in East Asia first or Africa first and then North America later. It has to be essentially synchronous. Now, to a historian like myself, that's a peculiar requirement. You and I, as historians, are very comfortable with the Bronze Age having a different chronology in Southeast Asia and in the Mediterranean world, or with the Renaissance starting earlier in Florence than in Amsterdam. And we still find terms such as Bronze Age or Renaissance to be useful. But the stratigraphers see it differently. They require synchronous beginnings to every interval of geological time. And that also, for them, makes the middle of the 20th century look more plausible than anything else, because any of the other proposed birthdays for the Anthropocene fail this requirement. They're asynchronous. They start somewhere, and they may eventually become global in their impact, but they do not meet this fundamental requirement of the stratigraphers. Now, one might very well say, why should one bow to the requirements of stratigraphy? Many people, especially in the social sciences and humanities, who use the term Anthropocene, don't want to do that. But because I've been working with stratigraphers and geologists for 12 years now, and because ultimately the suffix CENE, seen, is one that was developed for compartmentalizing geological time and is used, at least until very recently, only for that, it seems to me acceptable that the geologists should have a stronger voice in the designation of the Anthropocene than anybody else. After all, if, as a historian, I was subjected to stratigraphers trying to redefine periodization of Chinese history, I would find that objectionable. So I'm prepared to defer to their expertise and their standards, although I have to admit it's convenient that the conclusion that they arrive at dovetails with the conclusion that I had arrived at for different reasons. But if it weren't for the requirements of geology and stratigraphy, I could see a much more gradual advent of the Anthropocene without any specific birthday. But that's not the way geology works. They have to have sharp boundaries, a before and an after, and a marker for that, which is what the Anthropocene Working Group is doing right now. Every interval of geological time ideally has to have a marker in the rock or ice, the so-called global stratigraphic section and point, colloquially sometimes called a golden spike, that signals what came before and what came after. And about 75% of officially recognized intervals of geological time do have a GSSP, and those that don't will eventually get one when the stratigraphers settle on one. So right now, the Anthropocene Working Group is consumed with considering 12 possible GSSPs that would mark the so-called lower boundary of the Anthropocene. And when one or possibly two is settled on, then the formal proposal will be made, and bodies within the International Union of the Geological Sciences will vote on this, which is another peculiarity from the point of view of historians. We don't vote on
No.
periodization, but the geologists do.
This is a very peculiar process, and you are one of the very few historians in this working group. What can historians bring to the table to a full house of geologists or stratigraphers?
So I'm one of two historians. The other is Naomi Oreskes, a historian of science. In some of her early work, she wrote about geology and geologists. There are also some other non-stratigraphers. There's a lawyer, there's an archaeologist or two. There's a small smattering of people who are not geologists, which is unique. The other working groups, there are, I believe, 4 working groups dealing with the Quaternary. None of them have anybody but geologists on them. And this, I might say parenthetically, is problematic for some people within the profession of geology. They regard me as illegitimate and an interloper. We are altogether perhaps 8 or 10 out of about 36. So what can historians contribute? I can be useful correcting minor errors that my geology colleagues make when writing about historical phenomena. Sometimes I can push them to reduce the jargon a little bit and make the papers clearer to non-specialist audiences. I don't want to paint myself as a central member of the Anthropocene Working Group. The really central members are the geologists themselves, and that is as it should be. I find it highly educational to work with the geologists.
Thank you for the description about the work. I think you're very modest about your own contribution to the working group. And I see your point that, Anthropocene ending with the suffix CENE justifies this be studied or understood as a geological term. But I am thinking now, especially in the public opinion of the word Anthropocene, people think beyond geology. So I wonder, should we also consider this in terms of, for example, climate change, the atmosphere, biodiversity, or desertification? So these are all areas that humans have or are still leaving ecological footprint on these areas. So should the working group, should they also consider the inputs or the perspectives of atmospheric scientists, biologists, or ecologists, in addition to archaeologists, historians, and the geologists?
Yeah, and to some extent that is happening within the Anthropocene Working Group, because I perhaps should also mention there's at least one paleobiologist. While Paul Crutzen was alive, there was at least one atmospheric chemist. And there is one ecologist, at least one ecologist, who's often a dissenter from the consensuses that tend to emerge within the Anthropocene Working Group. So these sciences are represented. Anthropocene Working Group does try to understand the Anthropocene in an interdisciplinary way, not just as a matter of geology, but as a matter of the Earth system. For example, the fundamental biogeochemical cycles, the carbon cycle, the nitrogen cycle, sulfur cycle, the water cycle. These are governing systems for the Earth and life on Earth. The Anthropocene Working Group often thinks in these terms, not just in terms of sediments and rock and ice. But all that said, the term Anthropocene has escaped the control of geologists and stratigraphers several years ago and is widely used. In fact, it's more widely used in literature than any other discipline. I'm not sure where that's going to lead. One direction that I think it's leading in is more confusion. If everybody means something different by the term Anthropocene, then its utility diminished. I am hoping that the geologists will formally adopt it and give it a precise definition. And I'm hoping that should that happen, the amount of confusion would be reduced and people would use it to mean what the geologists mean by it. And by and large, I don't find it helpful to try to use the suffix CENE for other things. The Plantationocene, the Capitalocene, the Wasteocene. There's at least 20 ocenes in circulation. And the underlying ideas behind them, I think, are usually valid. Let's just take the Plantationocene as a random example. The advent of plantation agriculture was important in human history in social terms, economic terms, political terms, and ecological terms. And it should be recognized as such. To me, that does not, however, justify a term such as Plantationocene, which, because of the suffix, implies that it is an interval of geological time, which I don't think it is. I think our discussions could be made a little bit clearer if the enthusiasm for ocenes would die down and if the geologists would go ahead and formally adopt Anthropocene. In some respects, the term that Crutzen popularized is unfortunate because it has led to arguments. If Crutzen had come up with a different prefix than anthropo, it would have led to less confusion and more clarity, because many people object to the term and concept Anthropocene because anthropo seems to elide difference and inequalities. For geology, the suffix does not imply causation. It usually comes from something innocuous, like the place where a certain fossil was found. But by choosing anthropo, Crutzen inadvertently created a set of objections that are very lively in some scholarly circles. And the work of the Anthropocene Working Group would have been smoother if it weren't anthropo, but were something innocuous.
Such as?
Well, let's take the Jurassic, which everybody knows about because of the movies Jurassic Park. So the suffix there comes from the Jura Mountains in France, where the lower boundary for the Jurassic is found. And it doesn't imply that the Jura Mountains caused the Jurassic period. They didn't. It doesn't imply responsibility. It is innocuous and essentially random. Anthropo as a prefix does not achieve the same effect. Instead, it achieves incitement. I think that's made the term less useful than it might otherwise have been, although it may also account for some of its popularity and notoriety.
It puts human anthropo in the center of it, to be blamed and also to take responsibility. So that can make this more complicated. And lastly, I have a question for you from Prosenjit. He wants to ask you, do you think renewable energies can solve the problem of global warming?
They are an essential component of any solution. And by solution, I mean slowing the rate of warming of the lower levels of the atmosphere and of the oceans. It's not as if this can actually be stopped in its tracks at any point, but it can be slowed. And it's really important that it should be slowed because the warming now is roughly 100 times faster than any in the record of Earth history that we know about. So slowing it, even if it cannot be stopped in its tracks, is an extremely important goal. And that requires reduction in greenhouse gas emissions, carbon and methane above all others. And renewable energy can go a long way towards sharp reductions in greenhouse gas emissions. I would not go so far as to say that renewable energy can eliminate greenhouse gas emissions. I don't think there are realistic scenarios in which that would happen. I would not go so far as to say that even widespread adoption of renewable energy would slow the warming of the lower levels of the atmosphere and the oceans enough to ensure stability. It might very well also require some form of carbon sequestration. So what I'm talking about is taking carbon out of the atmosphere and burying it underground. That is the reverse process of burning oil and coal and natural gas, in effect. At the moment, there are various ways to do this. None of them are economic, and scaling them up from the sort of experimental to the consequential is a nut that no one has cracked. Lots of people are working on it. It might become viable. Smart people are divided in their opinions about the advisability of doing this. Some say it really has to be done because otherwise there's going to be too much carbon. Others say it creates a moral hazard. If you can sequester carbon on a large scale, it eliminates any incentive to check the greenhouse gas pollution. And so don't do it. At the moment, knowing what I know, which isn't everything that's relevant, I would fall in the former camp. That is, if we don't do it, there'll be too much carbon. So we probably should do it. I also say that because there are putative solutions that I don't want to see. Here I'm speaking about various geoengineering schemes, such as injecting aerosols into the stratosphere to reduce solar energy reaching the earth. And the reason I don't like that idea is because it's really hard to do only one thing at a time in large scale ecosystems, earth systems. And what else would happen by accident in that scenario? Let's say to rainfall patterns. And the other leading geoengineering scheme is to seed the oceans with iron filings to stimulate phytoplankton growth. And the phytoplankton will, in effect, suck some carbon out of the atmosphere. This is actually being done on experimental scales. But the issue there is what else happens to marine ecosystems if you stimulate phytoplankton growth on the kind of scale necessary to reduce carbon dioxide concentrations in the atmosphere. Again, unintended consequences. So among the bad alternatives, among the bad choices, I reluctantly would endorse carbon capture. But among the good choices are renewable energy and maximizing the proportion of human energy use that is in the form of solar, wind, geothermal, tidal, etc.
All right, John, thank you so much for your time. It's a privilege to have you here.
Yuan, you're very welcome. Thanks for listening.
Thank you.